The first question that she had was on question 6, which is the CSO problem over here. So my carbon's going in the middle. We're going to do this again today. We're going to do this again today, aren't we? Okay. Yes. I just need stuff to work, you guys. Okay, let's try it with this guy. So my carbon is here. I'm going to put that off to the side here. I'm going to leak an oxygen, and I'm going to leak my sulfur here. I had four valence electrons from the carbon. From my sulfur, I have 6 each. So 4 plus 12 is 16. So I've got my sulfur here. I have 16 electrons to play with. So I'm going to put 2, 4, 6. So that's 2, 4, 6, 8. This is 10 and 12. And I have 14 and 16 left over. So I'm going to double bond here and double bond here. Okay. So Ray had asked me via email if my formal charge, which I had as 0, was incorrect. Okay. So let's see here what our formal charge would be on our sulfur. Our sulfur should have 6 valence electrons. Remember, we count the columns. We go 1, 2, 3, 4, 5, 6. Okay, and that's where sulfur is. So you know how to get the 6 now? Okay, so that's my should minus my has. Now, this is the only time that you count these lines as 1 electron, is when you're calculating the has amount. Okay, so I'm going to count these. 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. So my overall formal charge for my sulfur is at 0. Carbon should have 4. I count my columns. 1, 2, 3, 4. That's how I get my should amount. My has amount, I'm going to count how many things are around here. Remember the line, the only time the line counts as 1. 1, 2, 3, 4. 4 minus 4 is 0. Oxygen is in the 6th column, so it has 6 valence electrons. We're going to count these. 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. Then we go along the bottom here to find out the total formal charge for this entire molecule. The entire molecule then, 0 plus 0 plus 0 is 0.
What's the bond order? Is that just
did I get to bond order with you guys yesterday?
You did, but she wasn't here.
I know she wasn't, but out of my 4 classes, every class ended in a different spot.
Oh, I see.
So I can't remember which class ended where. So bond order, if we're looking at the bond order for this molecule, you are going to count how many bonds you have. So I have 1, 2, 3, 4 bonds. So it's going to be 4. And then I look at how many spots are bonded. I have 1, 2. I call these sites. Okay. So 1, 2. So 4 divided by 2, my bond order here is going to be 2.
Would you be able to do problem 5?
Yep. So on problem 5, which is right here, we have sulfur. And we need to calculate our electrons. So here for my sulfur, I'm going to have 6. 6 plus my oxygen is 6, but I've got 3 of them, so it's going to be 18. And then this is a polyatomic ion. So it's going to have 2 more electrons added in there. So that gives me a total of 26 electrons that I'm working with for number 5. Okay. I'm going to go around and I'm going to put my oxygens out here. And I'm going to start working on outside in. So I'm going to start, right now I have 6 electrons placed with these bonds that are present. So 6, this makes 8, 10, 12, 14, 16, 18, 20, 22. Did I count these right? Six, 8, 10, 12, 14, 16, 18, 20, 22.
That's short. They usually put 2 on sulfur, right?
Yeah.
Oh, yeah. Yeah. So sulfur is going to get 2 here. This isn't turning out right, though.
Yeah, oxygen has like 1 too many.
Because this should be a double bond here. So, I'm so done with that smart board. 2, 4, 6, 8, 10. So this is 16, 18, 22, 24. Did I miscount? 8, 16, 20, 22, 24, 26. Yeah. So those need to come off of.
Was it supposed to be a +2?
No, it's a -2. This is sulfite is what this is called. 2. So this is 8. This is 16. 16. 16.
You added 2 instead of subtracting 2 up top.
Yeah.
26.
Because it's
That-
2 on
Because it's electrons.
But
16, 18, 20, 22, 24, 26. Yeah, I have this right. 16, 18, 20, 22, 24, 26. All right. So we need to talk about this guy. All right. Notice that your oxygen here has its requisite 8. This one has 8. This one has 8. Our sulfur has how many?
10.
10. Okay. And you're like, yep, I see that. Look, that's exactly where you should be right now, because I have not talked to you about something called an expanded octet. Okay. So when we talk in terms of an expanded octet, anything that is silicon and higher can expand its octet, which means it can allow in more electrons than 8. Okay? So anything silicon and above, oh, I have to write on this thing. Anything silicon and above can expand its octet. Are you wondering how that works?
Kind of, yeah.
Okay. So let me take you over to a periodic table. I'm just going to use the one yesterday that I might use the one yesterday. Here we go. This is what I needed. Yesterday we looked at, here's a periodic table. This is just one that I can kind of point to. Okay. This is actually electronegativities. But remember, so we're talking about like silicon and all of these guys. Remember that this here, what level am I in for my electron configuration? This guy here, this line, 3.
3, yeah.
Okay, so 3, level 3 also has a D level that is present. It's just not used. Okay, so these guys can expand into that D section, and they can actually accept more electrons than just 8. Oxygen and these guys can't do that though, because there is no 2D level.
Is there a certain like amount of electrons that they can?
Yeah. So like sulfur, I think it can accept 4. I think chlorine can, I have to look it up, but
It's okay.
but yeah, it's usually between 4 and 6, right around in that range. Okay. But that's how sulfur can have 10 electrons and still be fine. Because otherwise, when we're talking about this problem here, we have more electrons than we have spots for them to go. Okay. So that's called an expanded octet. So we have reduced octet. What's the only element that we deal with a reduced octet with? Boron.
Boron, yep.
Boron. Boron's happy with 6. Okay. So that's reduced. And then silicon and above, they can all expand because they can go into that D level. Okay. So when we're looking at these, in terms of these guys, I'm going to see if this will let me switch over pen color. When we're looking in terms of these, this oxygen, its formal charge, that oxygen should have 6 valence electrons. So that's my should. I got that off of the periodic table, right? 1, 2, 3, I just count the columns. Should minus has. Has 1, 2, 3, 4, 5, 6, and the line counts as 1, giving us a total of 7. So the formal charge on that oxygen is going to be a -1. My sulfur here, it should have 6. It has 2, 3, 4, 5, 6. Its formal charge is 0. This oxygen here, 6 minus 1, 2, 3, 4, 5, 6. Its formal charge is 0. And then this oxygen down here is going to be an exact repeat of this guy up here. So it's going to be a -1. Okay. Now, if we go and we count up our formal charge for the whole molecule, it's a -1 plus 0 plus a -1 plus a 0. So its formal charge is going to be -2. And that formal charge should be the same value as the negative on that ion. If you have a molecule, your formal charge should always add up to be 0. If it doesn't, you've done something wrong. We also denote that there is a charge on this by using these square brackets to do that with. Yes.
What should add up to 0?
The formal charge on a molecule. So see with this problem here, if I add up the formal charges across the board, they all add up to be 0.
So they're all just zeros.
Well, these are all zeros, and that 0 plus 0 plus 0 is 0.
Oh, but then like, if you have like a -1 or in the 0,
If your formal charge adds up to be something else, then that formal charge should match what you had for your molecule here. Okay? So this formal charge should match this guy here and here. All right, then if we look at the bond order for this, you guys were talking about that as well. This has how many bonds? Well, we have 4 of them. Over how many sites? 3, which gives us a 1.3 for our bond order. So this bond over here, this guy over here, is going to be stronger than this. It gives you an indication of the strength and stability of that molecule or ion. The higher this bond order, the more stable that is. All right. The next question that you had was on number 10, I believe.
Yeah.
Okay. All right. So number 10. This would be so much easier if I could just sit down. I'm so done with the smart board, guys. Just so done with it. All right, so let's count up our electrons. We have our, where's my pen here? Oh, this is upside down. That's why everything's backwards. Okay, here we go. So I've got 4 for the carbon. My nitrogen, I have 5. My oxygen, I have 6. And then notice the minus sign here. That's going to give me an extra electron to work with. So that gives me a total of how many electrons?
16.
Yep, 16. Okay, so 11, 12, 12 and 4 is 16. That's how many I've got to work with. So my carbon is going to go in the center here. I'm going to attach an oxygen, and I'm going to attach a nitrogen.
Oh, so it doesn't matter if both ways run through the
Yep.
That's what I was wondering about.
Sorry. Now, I'm going to start going around here. Sorry, you guys. And I'm going to start putting my electrons, and I'm going to probably do this wrong to begin with because I want to show you some stuff, okay? So if you want to kind of watch what I'm doing more than writing out. Okay, so right now I have 16, 2, 4, 6, 8, 10, 12, 14, 16. What's my problem? Carbon doesn't have enough. So if I take these two and I bring them in here, this is still going to be wrong. Don't write this stuff down, okay? Okay, now this looks like a valid structure based on what you've learned so far, right? Everything has 8, but let's look at our formal charge on these things, okay? My nitrogen, I have 2, it should have 5. It has how many?
6.
Okay, so 5 minus 6 is a -1. My carbon should have 4. It has 4, so it's good. My oxygen should have 6. It has 6.
Oh, I see.
Okay, now this again still all adds up to that negative value there, which it should. But if you look at your table of electronegativities, remember we've looked at this, oxygen is more electronegative than nitrogen. So that charge, that negative value here, we don't want that on nitrogen. We want that on oxygen. Okay? So how can we rearrange this to make that work? Well, what I can do is I can take these 2 electrons and pull them into here. And I can take this guy and bring him out here. Now we're going to reevaluate our values for formal charge. Nitrogen now has how many? 5. Because when we calculate has, it's the only time, but when we calculate has, that comes down to, yep. So that is a 0. And now over here, oxygen is up to a -7, which gives us the formal charge of -1. We have a -1 here. Okay. Does that make sense why this structure is preferred over the first 2 that I drew?
Yeah.
Okay. So that is what I'm saying. Like, we're on Tuesday when I first started this, that one that I had done, just a few minutes ago where I had both of these double bonded. A few days ago, I would have had to have accepted that as an answer because you guys didn't understand formal charge. But now that you have formal charge, you can understand that this is the way it is. And I will give you a table of electronegativities. You do not have to memorize them. Okay? So don't stress over that. Now, let's figure out bond order. We have 4 bonds over 2 bond sites. The bond order for the whole molecule is 2. Yep.
Do you do the same thing you did for number 5 on number 7? You give nitrogen like extra.
No, nitrogen cannot expand its octet.
Oh. I'm looking at these.
So nitrogen can't expand its octet. Any questions about this one before I go up to 7? Okay. All right. So remember that in order for it to have an expanded octet, those valence electrons have to be in the 3p, 4p, 5p, 6p, 7p orbitals. Okay, because otherwise there is no 2D. This does not exist. So all of these level 2 elements, they can't expand. They don't have anywhere to go. Okay, so how do we draw this? Well, let's count up our electrons. We have 5 for here. We have 18 for our oxygen, plus our extra 1 here. So 6 and 18 is 24 electrons. Okay. So nitrogen's going to go here. I'm going to have 3 oxygens coming off of it. And then I'm going to start getting my electrons placed. So this is 6, 8, 10, 12, 14, 16, 18, 20, 22. If I put the 24 here, which are my remaining electrons, then nitrogen is going to be deficient. So I'm going to pull that in. I'm going to make that bond. I'm going to go through. I'm going to put my square brackets here.
Now you have 2 negatives. Now you have a -2 as opposed to a -1.
Right. And that's just the way it's going to have to be because there's no other way to draw this structure. Oh, I see what you're saying. Okay. Let me do some magic here. Okay. So what you're saying is that I have two values here that are negative.
Yes,
Okay.
and
So that's these 2 right here. They're going to come in should minus has is going to give me a -1 on this guy. And it's going to give me a -1 here. But what with this guy, he is 6 minus 6. So he's going to be 0. You still have a problem with this. Watch. Nitrogen.
Okay.
Nitrogen should have 5, but it only has 4. So it is a +1. So this +1 cancels that guy out and leaves me with the -1 over all former charge. Bond order is 4 over 3, which is 1.3. The thing is, you guys got to practice these. That's just the only way it's going to come. All right, so we needed to talk, and I've got 4 minutes, and that's all it's going to take. We needed to talk about something called resonance. Okay? Resonance is where you can end up drawing a structure differently and still have the same results. Okay? So I'm going to just take this guy for an example because it is just easy to kind of work with, and I've got a little bit of space here. Okay? I can draw this nitrate as this. Where I have that double bond, instead of being positioned here, now I have it positioned here. Oh, stop packing up. I could also draw this where I have the double bond positioned over here. That's resonance. Told you I could do it in 4 minutes. And so when you can draw it in different ways and have the same result, those are called resonance structures. I could do the same thing. Do you see where I could do the same thing for this guy here? Okay. I'm trying to think if there's other ones here.
Resonance and structure are present simultaneously.
Yep. So you can read through this verbiage if you'd like, but that's essentially what we're looking at as far as resonance. So I want the rest of this. You should be able to do this entire thing now that you know what an expanded octet is. You should be able to finish this assignment up for homework tonight.
Okay.